Hey everybody. I did not get better over the weekend. I got worse. So I'm home again. But I didn't want this day to go by without you getting a chance to review some of the new learning that we've done. So I don't have that much. It is just those topics over there. And then I'll give you some practice problems to do, okay? So we learned that probability is how mathematicians decide how likely something is to happen. And they have a formula for it that you learned. It's this: capital P for probability equals the number of desired outcomes, the ones that you're looking for, hoping to get, over the total number of outcomes. Okay? And you folks have done this. You showed that you knew it already. When I said, hey, flip a coin, what's the probability that you get heads? You all knew. Some of you said 50-50, but once we straightened it out, you gave me three options. And that's very typical to see probability either as a fraction, or as a decimal, or as a percentage, 50%. That's what it is for flipping a coin once and getting heads, right? And then it turns out, so look, we're done. Like, there's not anything tougher about probability. That's the formula for it. The tricky part, the part that makes us get probability problems wrong usually, is figuring out this bottom number right here. Like, what are the total number of outcomes? That list of outcomes is called the sample space. Okay, so that's what I'm going to say. That's what I'm going to talk about next. Trying to get that sample space, boy, if you can get it, then you're great. You're golden. It's going to work fine. If you mess it up, you won't get any of the problems right. So let me show you three ways to get a sample space, okay? The first way is just to think about it. If the problem isn't too tough, you might just be able to get the sample space by just thinking about it. For instance, one of the ones that we did in class last time was, hey, what's the sample space for if you flip a coin twice? Twice. So that one's actually not too hard for me. Here it is. You could get heads, heads. You could get heads, tails. Or tails, heads. Or tails, tails. And guess what? That's it. There are no other options. And what's nice about that is once you know that, the bottom number here, the total number of outcomes, can you tell there are 4? So whenever I ask you for the probability of, like, let's say, what's the probability that you have exactly 1 heads when you flip a coin twice? Well, here's my probability formula. So P equals the total number of outcomes, 1, 2, 3, 4, bam. And then just look at it. How many of these have exactly 1 heads in them? Not that. This one does. This one does. That one doesn't. So the probability of getting exactly 1 heads is 2/4, okay? Or 1/2. So that is sample space by a list, okay? Where you just list them. But it can get sort of difficult sometimes if your probability problem is tougher. So, for instance, we saw one last class where we were like, hey, what about the probability that you flip a coin 3 times? Well, some of you were actually able to get all 8 possibilities. But let me just go through that using a tree diagram, and that way you'll see that you can get all 8 possibilities a little bit more easily, even though it takes up some space. But it almost guarantees you won't miss any, okay? So, let's say we're flipping a coin 3 times. How do you find the sample space? Well, check it out. Here's what we did. And you can follow along if you want. So I just put a little dot here, and I'm like, okay, when I flip the coin first, I can definitely get a heads or a tails. Then, if I get a heads and I flip it again, well, guess what? I could get a heads or a tails. Okay? Or if I had flipped and got a tails, when I flip it again, I could get a heads or tails. Okay? And then just keep going. I just flipped it once, and then I flipped it again. And then for my third flip, if I got heads, heads, well, I could get heads or tails on that last flip. Same thing here. and then etc. down here, okay? So you can probably tell why this is called a tree diagram, because it looks like a sideways tree, right? But the nice thing is this. You can just read along the branches and get every single possibility. Like, could you get heads, heads, heads? Totally. So list it. Could you go heads, heads, and then let's take this branch. Tails? Totally. So list it. And then heads, tails, heads. Heads, tails, tails. And then we go down to this bottom branch. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. And can you see how that gives me, here, let me draw a line for you. That gives me all 8 possibilities, and I know I got them. I don't have to worry about, oh, did I miss one combination or anything like that, because when you use a tree diagram, it just organizes all your findings. So I recommend that. Like, if you get hit by a problem here, and you're like, I don't even know what the sample space is, I can't even think about it, I'm going to get messed up. That happens all the time in mathematics. Just use a tree diagram, and it will often straighten out like your thinking, okay? So you can get a sample space by using a tree diagram, just like this. By the way, I should say, the whole point of getting the sample space is so that you can answer problems, okay? So, like, usually it wouldn't just be like, oh, find the sample space and then move on. Usually you'll have a problem like, hey, let's say you flip a coin 3 times. What's the probability of getting 2 tails? Exactly 2 tails. Well, check it out. Here's my probability formula. So what's the total number of outcomes? 1, 2, 3, 4, 5, 6, 7. There are 8 top possible outcomes when you flip a coin 3 times. How many of them have exactly 2 tails? 1, 2, and 3. So you know your probability for that is 3/8. Okay, so that's how you use the sample space probability. Okay, I got one more to show you. The chart is actually pretty useful. It doesn't like take up all the space that a tree diagram does. The one bummer you should know is it only works if there are 2 actions. Oops, where am I? Okay, it only works if there are 2 actions, okay? So if you're flipping a coin 3 times, can't use a chart. If you're flipping it twice, chart's perfect. Or the other classic example is if you're rolling 2 dice, then perfect. The chart's perfect. So let me show you how to get a sample space using a chart, okay? Okay, so let's flip the coin twice, okay? So watch this. Look how easy this is. If this is my first coin up here, you could get heads or tails. And if this is I'm going to make space for my second coin down here, its outcomes, and that could be heads or tails. And then you just sort of fill it in like your times tables from elementary school. So here's my first coin, here's my second coin. So I could get a heads, heads. I could get a heads, tails. I could get a tails, heads. Put that in there. And a tails, tails. And then check it out. Do I have all of my possibilities? Yeah. And so there are 4 of them, and then you can, keep going. Like I said, it only works if you're doing 2 actions. Like you're rolling the coin twice, or flipping flipping the coin twice, or rolling 2 dice. But that's another really useful way to organize your sample space, okay? So I hope that works for you. You should be able to now try some practice problems that are up on the supply table. I think the worksheet is labeled Practice with Sample Spaces. I think you can do numbers 1 through 6, okay? Not 7 and 8 yet. All right? See ya.